My name is Hong Yan Yi and my group member is Liao Jingyang. Today we are going to present about the machine learning application for Google Play Store app analysis, prediction, classification, and clustering. This is the agenda we will present as follows. Since 2012, Google Play Store has grown to host over 1.5 million applications to track the million of user activity daily. And also application metadata such as the review, install rating is widely used to analyze application performance and user satisfaction through machine learning. Besides, the k-nearest neighbor and the random forest models predict application ratings based on install and review counts. And also the TF-IDF and Ensemble learning techniques analyze user review to recover and predict authentic application rating. Last but not least is the application data involve complex non-linear relationship and diverse segment requiring advanced pre-processing and specialized modeling. This is the literature review categorized using the taxonomy mapping. They have X section, which is the data set, problem statement, features, data cleaning and pre-processing, EDA, hyperparameter tuning, model evaluation and validation, and last is the machine learning algorithm. Now it's about the problem statement. The first one is the data complexity, which means need to diverse data type such as the category, number, text, and need advanced pre-processing. The second one is non-linear relationship, which means the application feature and success metric have complex non-linear connection. The next is the market segmentation challenges, which is the different application type require specialized tool to identify success factor. And last one is the feature interaction complexity, which is the understanding attribute interaction demand advanced modeling beyond basic statistics. For this study, we aim to find out which factor influence application ratings, how well the machine learning predict the installation, and what natural application segment exists. And also we need to examine which feature best predicts success and how size, price, and category relate to user engagement. They have several objectives for this study. The first is to specialize pre-processing technique. Then is about the prediction models for rating and installation. The last is to unsupervised learning to identify strategy application categories. Now is about the data information for the project. The collected data set comprise 10x41 rows distributed across 13 columns. They cover a broad spectrum of application characteristics such as the ratings, reviews, installation, size, and prices. The available information represents numerous application types varied by their user adoption rate. Now is about the methodology. The first one is the data pre-processing. So for first one is the handling missing value and standardizing data. The missing value will fill using the median or mood and feel like install size and price were clean and accurate analysis. Then the second one is managing duplicate and outlier. The full duplicate will remove version specific one keeps and the outlier will treat carefully to maintain natural data distribution. Now it's about the EDA. The first is to understanding the distribution and patterns. So such as the univariate analysis, show right skip distribution in review, install, and price using the histogram statistical summaries. Then the next for the EDA is the analyzing relationship between the variable. So for example, is the bivariate analysis found strong correlation between reviews and install and significant association between content, rating, and the category. Then the next is about the feature engineering, which is the feature transformation and encoding, such as the logarithm scaling, normalization, and encoding prepare the feature for machine learning model. Then the next is about the market segmentation, where the application were grouped by installation and price tiers for better category comparison. Last but not least is the machine learning model. The first is the supervised learning model, such as the gradient boosting predict the application ratings, random forest classification the application based on the install level. The last is the unsupervised learning and dimensionality reduction, which means the k-means clustering reviews 6 application segments and the PCA visualize the feature relationship. And the last methodology is the implementation tools such as the Python with Pandas, NumPy, Matplotlib, Seaborn, and the Scikit-learn were used. We all were conducted in Jupyter Notebook.
Next is about the result, and we start from the EDA univariance. This graph shows about the entertainment application together with family related and utilities, offering control the market incorporating important opportunities and usage trend. The next result is about the type is categorical as free and pay. So the visual graph shows that the most developers give away their application at no cost because they want to appeal to the large possible user base. Next univariance is about the numerical, and then this is the rating. So based on this graph, we can show that the most higher frequency is about the 4.3 rate. Next, this size is megabytes, and then this pattern aligns with the practical needs of mobile users who prefer smaller application download for faster installation and lower data consumption, especially in markets with limited internet speed and data plans. Next is about the bivariance, and then we can, according to the plotted data rating, show only a minimal associations with other investigate variables, so application quality stand mostly autonomous from application, dimensions, cost, and usage pattern. Next, we also can find in this chart, and then it shows about the user mostly depends on application which enable communication and handle social networking tasks along with media consumption capacity. Knowledge of the specific patterns direct developer and marketer towards application categories which user prefer to adopt. Next is about the average price in USD by category. We can specialize features in financial management and lifestyle improvement, generate user willingness to pay, whereas everyday utility program remain available at very low or free cost. And then this result is about the machine learning algorithm which is using the regression, and then the feature important for gradient boosting bar chart identified which attribute the gradient boosting regressor depends on most in its rating prediction. So this graph shows which factor present in the application drive the most significant impact on predictor rating result. Next is about the classification using the random forest. This is also one of the machine learning algorithm supervised. So we can see the confusion matrix for random forest. Heatmap present the model classification result by comparing the predicted install class with the true classes. So the random forest model show exceptional performance in identifying high and low install application because of its well-distributed strong dynamo domains. Next result is about the clustering using the k-means, which is the unsupervised. And then the visual representation show that the application can be categorized explicitly through their rating combined with their size and review as well as their price point from market segment studies. The last result is about the dimensionality reduction using the PCA. So from the first graph, we can see that the less than half of information in the dataset existing in characteristics detected in the first two principal components, which make this reduction feasible for exploration and cluster creation purpose. For the second graph, the plot provides quick understanding of principal components, meaning by showing which variable contribute most the record data variance. Next is about the limitation and future study. I will talk about the limitation first. So it will be categorized into two limitations. The first is the data limitation. The first data limitation is cross-sectional data only. So the single time point snapshot miss application marketplace evaluation. The second is a missing contextual factor, which lack user demographic, geographic distribution, device types. And the last is the incomplete monetization data. So no information on purchase, subscription, advertisement revenue. And then the other limitation is about the methodology limitation. The first is about the model performance constraints. So there are limited predicted power, suggests missing key factor. And then the second is the binary install classification, because oversimplifies the continuous nature of install metrics. The last is about the exploratory clustering. So the k-means segment provides indicate patterns rather than definitive categories. Next is about the future study. The first is maybe we can enhance data collection like incorporate user demographic, regional usage pattern, and device-specific behavior. The second future study maybe is the advanced modeling approach, like maybe applies time series analysis to identify earlier success indicator, or also develop multi-level classification for nuisance installation tire prediction. The last is expand analysis scope. So maybe can conduct cross-platform comparison between Android and also the iOS ecosystem. Besides, we also can investigate revenue optimization strategy across different application category. Next section is the conclusion. As a conclusion, our team successfully demonstrate machine learning effectiveness because we apply the 4 machine learning approach to Google Play Store data. Like we combine the supervised learning like the gradient boosting random forest. We also combine the unsupervised techniques like the k-means and also the PCA. And then the last is a key insight uncover. So the first user review most critical factor from predicting both rating and installation level. The application size is significant but no impact on user adoption and rating. The third is pricing strategy. So different effort across application category with premium pricing viable in specific segment. And the last is marketing segmentation. We identify 6 discrete application cluster with unique performance characteristics. That's all for our group. Thank you.